right, so we are at script number 3 for our end-to-end project on calculating rainfall deviation. This is the kind of core of the whole project, and we'll learn how to now take this penta data and aggregate it over a month and calculate monthly average over the last 30 years. And this requires the skills on how to iterate over different lists and how to aggregate data across them. So you learn a couple of new skills, and you also, the skills of iterating is very important on how you do that in Earth Engine. So here we want to compute the average rainfall for a given region over the last 30 years. And the long period average is defined as 30 years or more. So first, let us set up some variables. We have a list of years from 87 to 2016 and list of months from 1 to 12. Let's just print those and see what they contain. So LPA years is now a list of 30 years from 87 all the way to 2016. And our goal would be to take the data from all of these years and compute the average of it. And then we have a list of months from 1 to 12 that allow us to compute that. Now, I want to introduce a really important function, a really important filter called calendar range. Remember, when we apply a filter, we can apply a date filter where we give a start date and an end date. But in this case, we want to filter, take the chirps collection and filter to all images that belong to January. And then that way we can now compute the January rainfall. So how do we do that? And that gives us, that is used. We can do that using this really important filter called calendar range. So if you search for it, this is the calendar range function. And it takes 3 parameters, the start, end, and a field value. So you can say, give me a calendar range filter, which starts at month 1, ends at month 1, and the field is month. So that means it'll say, I'll take this whole collection and give you all images that match, are from the month number 1. Similarly, you can say, give me all the images that are, on Mondays, for example, and you can say day of the week. So day 1 day. So you can, the field value is the, what is the step that you want to compute over, and then start and end of that. So in our case, if you want to do get all images for July and want to compute the July average, you could say, give me calendar range start at July 7, end at July 7, and the field is month, and then we can apply that filter. So let's just first try it out on the data sets. So we have a chirps penta data. Let's just compute, say, a variable called July images. Let's just filter this whole collection with only images that are from July. So I'll take chirps and apply this filter. You can say EE filter calendar range. You can do control space to complete. And we can say, what are the 3 parameters? It takes a start. So we can say start at 7, end at 7, and the field is month, right? So now if I print this, you will see that it contains 240 images. And if I expand, this will be images from July across the different years. So you can see the images start from 1981 July, ends, and then goes 1982 July and all the way till the current time, right? So this is the very useful to filter stuff by month, by week, etc. So I'll just remove this for now, and we'll use this to now compute the monthly averages across the 30 years. So we have to write a loop, right? We have to iterate over each year and then compute the first monthly total. Remember this from our presentation. Where we now have to compute this, where we want to iterate over each year, and for each month, we want to compute the total sum. So how do we do that? We'll start writing the loop. We'll just say monthly images equals to, first we'll iterate over the years. So we can say LPA years And we want to map a function, and the function will take the year, and then we can do something with that year. So we can say map, and this is the function. So when we're mapping over this LPA years, each function will get each value for each iteration, and that will be the year. So now we can, we are inside the function, and the function has, we have to write this function for 1 year. And when we map it over the years, we'll get the values for each year. So now we are in the year, we want to do it, the sum per month. So we'll just say, we'll compute the months, and we'll say for, we'll actually get the month image. We'll just say month total equals, we'll iterate over the months now. So we are in the year, now we are iterating over month 1 to 12. And now we can map this. Right, so this is kind of a double iteration where we are iterating over the yearly list, and for each year we are iterating over the each month. And it's not really iterate, we are mapping the function, but from programming terminology, you can think of as you are iterating over the years, and all of this will happen in parallel, because that's what Earth Engine does. When you map a function, each of this part of the function will be computed in parallel. So now we have the month and a year. What do? We can filter our data set. So we can say filter, we take chirps and apply 2 filters. We'll say EE filter calendar range, and we'll say give me all images for that year. So if you are on 1981, at this point we'll have all images from 1981, and we'll say dot filter again with another filter, EE filter calendar range, and this time we'll filter with the current month. So whichever month is in the loop, we'll filter it using that. Right. So this filtered collection now will have the images for that 1 month for that year. So if you are in the loop where we are in the 1990s, it'll have all the 1919 July images. And once we have that, we can now get the monthly total, which will be filtered dot sum. And we can then return this, and the return would be, we'll just say monthly total. And when we're returning this, this will be an image for that month, but it will not have any metadata. So if you want to further extract some stuff out of it, it will be hard. So let's just set some metadata before returning it. So we'll just say set, and we can give it a dictionary saying the month is the current month in the loop, and the year is the current year in the loop. So this part will return, we are here. So this part will have the monthly total, where for each month we'll have 1 image, and this will have 12 images here. And then we can return those 12 images here. And you can do a shorthand where you can say, rather than saving to a variable and returning the variable, we can just say compute this and return this. So you might see a lot of code like this, where you just say, when you're doing this kind of 2 loops, it will say iterate over this, and whatever is the result of this loop, just return that. Right now, let's just print this. I'll name monthly images, and I'll print this and see if it works. And don't worry if it doesn't work for the first time. This is quite a complex loop. So we got 30 items, and each of the item has 12 more items. And that is expected, right? We did 2 loops where we had first iterated over the 30 years, and for each year we iterated over each month. And if we expand this, we'll see that this one is the month 1, 1987. This is month 2, and so on. So we now have a list of lists where we have a list of 30 years, and within that list, we have a list of 12 months. Right? So this one is fine, we got this, but we can't really make it a collection. To make it a collection, we need a flat collection where we just have a bunch of images that we are we have that in the collection. So that's is a good time to introduce this new function called flatten. So let's see what that flatten does. So let's say we have a list like this, where we have a list of lists. So a list, the first item is A, B, C, D, E, F. Let's just print that and see what it looks like. And you can see now this list contains 3 items, which are these 3 lists, and each list contains this different elements. This is very much like our list, right? We have 30 elements, and each of the element has further 12 elements. And we can't kind of put this in a single collection. To put it in a single collection, we need to create a flattened list. So we can just say, we'll take the nested list and apply this function called flatten. And when I print this flattened list, you'll see how is that different. So you can see now this list is flattened out, where the list of lists are now merged into a single white list. And that's what flatten does. So in this case, we'll apply this to our function, where we'll have this whole output, and we'll just add a dot flatten at the end. And that when I do this, you'll see the change, where we now have 360 images, because we have 30 into 12. And we have, for each of the years, we had a different image. You can see the sequence of images. And now that means we can now create an image collection. And to do anything useful with a bunch of images, we have to put this in the container called image collection. So we can now just say monthly collection equals, and there's a handy function called ee.imageCollection, and from images. And you give it a list of images, it'll create a collection. And we have a list of images. We have monthly images. So at this point, we have a collection, which is a collection of images for each month. So we have done this part. Right? We took our collection like this, which were the penta data, and we now created a monthly sum images. So now we have each year and a monthly sum image. So now we have to do this, where we now compute the average across all the years. And now we have a collection, so that is not very difficult. Let's implement that. So let's just say monthly rainfall. So we have monthly images, so let's compute the monthly average rainfall. And to do this, we need 12 images, right? We have images, 1 image per month across 30 years. And now we want to just take each month's image and compute the sum of that. So we can iterate over the list of months. We can say months.map, map a function. Each iteration will get the 1 month, and then we can implement a logic here. So we'll apply a filter on our image collection. So this is our monthly collection. So we'll take a monthly collection and filter it by what? The current month. And remember, we set a property where we set the month value to the current month. This is where it will be useful. So we can apply a simple equals function and say, look at the month property and match all the images from the current month. And this point, it will filter out, say if we are in the loop where it's looking at month 1, it will filter out all January images across all the years. So now we have, this collection has all the images of January, and now we can create a monthly mean. And you can also do reduce reducible. That's fine. And we'll just return that. And again, when we're returning this monthly mean images, it doesn't have any metadata. So we won't be able to identify which month it was. So we'll just set some metadata. We'll just say month, it's the current month. Okay, so now let's print this and see what happened. So we got 12 images, which were expected. And then this would be the monthly mean for image for the month 1, month 2, and so on. right? So now we have got our monthly images. So we have done up to this part where we have for each month, we have monthly averages over last 30 years. And that is very useful, and we can use it in the next step. But before that, it'll be useful just to kind of see this data and what it looks like. And one thing I always say is that when you do this kind of complex computation, always validate your results. Maybe by mistake, I did mean here and sum here, right? You'll get a very different result. So always validate. Now, how do we validate this data? We can take a region and chart it. And if I took the data for Bangalore, and I just did a search, what is the average monthly rainfall in Bangalore? And then I got a chart or some numbers, and then I can validate that because if my data matches that, then I did my computation right. So let's just try to do that charting. We'll look at the chart. We'll create a chart. So you look at the UI.chart function, and we have our image. So we'll do this one, image UI chart image series, and which will take an image collection. We have a monthly collection. We need a region and a reducer, and we all have all of that. So let's just try creating this chart. So we'll just say var chart equals UI dot chart dot image dot series, and control space to fill this parameters. We'll start writing image collection. What's our image collection? This is the monthly rainfall. Region, which region we want to create a chart over, and we have the Bangalore in the script altogether. Let's do Bangalore.geometry. What reducer? Now, this one has an average, monthly average for each month, and we want to do it over a region. We still want to do a mean on that. And the scale will keep it to 5,000, and that should be enough for our chart. Let's just print it. Oops, so it says no features contain non-null values of system.time start. And that is because we have, by default, it'll say on the x-axis, we need a time value. So remember here, the last one is an X property. And if we skip that, and this is an optional thing, and if we don't give that, the x-axis value, it'll just default to the default time of the image. And we don't have that. We don't have a system.time start property. But instead, we have a month, which, so we want to chart by month. So here, we can just add it back here. I can say X property, and that would be the month. And now it should work. Yeah, so we got a chart like this, and you can say month 9 in September in Bangalore, it rains about 191 millimeters across the last, as an average of last 30 years. And this is a kind of chart that you can find at many places for all the cities, and you can compare that data. I have some in the complete script. You'll find some more options. I'll just add those options for you to see what the chart looks like. So you can now make this chart a bit more pretty, and you see these are the options. You can say, give it the title, give it a vertical axis, should not be a band mean, it should just be, say, rainfall millimeters, and so on. And now after these options, you can see the chart will look much better. And now you can kind of see what the chart looks like. Okay, you can pop it out if you want. And now you can even download the CSV, and you now have a monthly average rainfall. So this is really useful data. You can try it for your city, and this itself is a very valuable analysis. So the important part here is that we did this looping over the years and then looping over the month. So this is quite a complex code. I would suggest you try to practice it yourself and try writing this loop yourself. Look at the code, listen to my explanation, and then try it yourself without looking. And by that, you'll really practice. And once you practice and understand how to write these loops, it'll really be valuable for any of analysis. So we'll move on to the next part now, where we'll compute the deviations.